Our lesson today is on the laws of exponential numbers. Laws of exponents. Laws of exponents. Today we shall learn how to use the first and second law of exponents. The first and second law of exponents. First of all, we start with the general notation for exponential numbers. The general notation for exponential numbers, for example, if we have a exponent n, this means a times a times a times a times a. Now we continue to multiply a until it reaches the number n. That is the meaning of a exponent n. This n is a particular number, and so we continue to multiply a until we reach that n. So a exponent 2 will be equal to a times a. Here n is equal to 2, so we have 1, 2. So n is equal to 2. Now this is what we call the general notation for exponential numbers. Now the next thing we shall learn is how to write a number in exponential form with prime numbers as the base. Prime numbers as the base. First of all, what is a prime number? A prime number is a natural number that is not a product of two smaller numbers. Or a prime number is a number that is greater than 1, but it is not a product of two smaller numbers. Another way of saying it is a prime number is a number that is greater than 1, but it can only be divided by 1 and itself. A number that can only be divided by 1 and itself, but the number must be greater than 1. So prime numbers, examples of prime numbers, we have 2, 3, 5, 7, 11, 13, and it continues as we go on. So these are called prime numbers. It can only be divided by 1 and itself. Okay, so prime numbers written. The next thing we shall do here is we say we are required to write each of the following numbers in exponential form with prime numbers as the base. So we have for expression 1, we write it as an exponential number with all its base as prime numbers. 5 is a prime number. 10 is not a prime number. What do we do? 10 squared means 10 times 10, okay, times 5. This is equal to 2 times 5 times 2 times 5 times 5. Here we have 2 into 2, then we have 5, 5, 5. This is equal to 2 exponential 2 times 5. Okay, let's write it downstairs so that we can see it properly. So here we have, because we have 2 and 2, 1, 2, so we have 2 exponential 2 times, we have another one, 5 exponential 3. We have 1, 2, 3. Okay, so this is our final result. So 5 or 10 exponential 2 times 5 can be written with base as prime numbers. So 2 is a prime number, 5 is a prime number. 2 exponent 2, 5 exponent 3, same thing as 10 exponent 2 and 5. Okay, so we have written the numbers with the prime numbers as the base. Now we have another one, 10 exponent 2, which we have 10 times 10 times 12. Here 12 is not a prime number, 10 is not a prime number. We can make them prime numbers by breaking them down into prime numbers. So we have 2 times 5 times 2 times 5 times 2 times 6. 6 is not an exponential, it's not a prime number. So we can break it down so we already have 2, 5, 2, 5. So we already have 2 exponent 2, 5 exponent 2. So we have 2 exponent 3, sorry. 2 is already exponent 3. 2 exponent 3, then 5 exponent 2 already, then times another 2 times 3. 6 is equal to 2 times 3. So what happens is that we reach the final. This will now be, we have 2 and 2 exponent 3, so we have 2 exponent 4 times 5 exponent 2 times 3. Now we have written the numbers in exponential form, all with prime numbers as base. 2 is a prime number, exponent 4. 5 is a prime number, exponent 2. Then 3, exponent 1. Okay, so that is for this number. Then we can do another one here. This one is 6 exponent 2, so we have 6 times 6 times 8 times 8 times 8 times 8. Okay, so we now have numbers that are not prime numbers. So we have to make them prime numbers. So we have 2 times 3 times 2 times 3. That's for 6 and 6. Now we have 8. 8 is 2 times 2 times 2. Another 8. 2 times 2 times 2. The other 8. 2 times 2 times 2. Then finally 2 times 2 times 2. So we've got a lot of number on our hands. So what do? We count. So we have 2 to the power 3, 2, 3, 2 to the power 3, 2 to the power 3, 2 to the power 3. So we have 3, 6, 9, 12, 13, 14. So we have 2 to the power 14. Then 3, we have 1, 2. Okay. Times 3 to the power 2. Okay. 2 is a prime number. 3 is a prime number. So we have expressed this with prime numbers as the base. With prime numbers as the base. So that is how it is done. You break it down until you get prime numbers as base. So having shown that, let's quickly clean up this one and finish up with the last one. So we can go on to do the last one. Okay, so the last one is 9 exponent 2. That means 9 times 9. 36 exponent 2. This is 36 times 36. Then times 4. 4 is 2 times 2. So here we have 9. This is 3. Okay, let's start from here. Let's start from here so that we have enough space. So we have 3 times 3 for first 9. 3 times 3, second 9. Then times, have 6 times 6. Then the next one we have 6 times 6. Then we have 2 times 2. Okay, so finally here we have 3, 3, 3, 3. So this is already 3 to the power 4. We have 6. 2 times 3, 2 times 3. So we have 2, 3, 2, 3. Okay? So we can go down to 2, 3, 2, 3. So we have 2, 2, 3, 3 for each of the brackets. For each of the brackets, we have 2, 2 times, 3, 2 times. So here we can just sum up. We have already 4 here. Okay, so 4, there are 2 3s here, 3 by 3, there are 2 3s. So 4, 4. Okay, so 4, 4 should be 8. So we have 3 exponent 8, then 2, 2 here, 2, 2 here, that's 4. Then there's another 4 here, and times 2 exponent 8. So that is what you end up with. 3 exponent 8, 2 exponent 8. These are prime numbers, okay? These are prime numbers. Okay? So we have them as prime numbers. We can further simplify this, but we want to leave it in this form because we are trying to have all the base as prime numbers. So the next thing we are going to do is to use law number, the first law. We just use the first law indirectly. Now let's see the first law. The first law of exponent says that if we have a exponent m multiplied by a exponent n, then what we are going to have is a as one base, then all the exponents will be added. So m plus n. So that's part of what we've done unknowingly. So if you have 3 exponent 2 times 3 exponent 5, this will give us 3 into 2 plus 5. Of course, this is equal to 3 into 7. That is what this law is saying. That's exactly what it is saying. Now, we take an example. Equation says simplify each of the following if a, x, and y are rational numbers. So we have the first one, 4 exponent 7 times 4 exponent 5. So from our first law, we write 4 into exponent 7 plus 5. This gives us what? 4 exponent 12. Now we have another one, minus 3 exponent 6 times minus 3 exponent 1. So we have minus 3, we have 6 plus 1. This is equal to minus 3 to 7. So you can see that the first law is pretty simple to use. Now a exponent 12 times a exponent 8. Write a 12 plus 8. And this is equal to what? A exponent 20. The final one, the very final number, we have 2 So first of all, we multiply the constants, but this is a multiplication. So 2 times 3. Okay. So we have x exponent 1 times x exponent 3. So we have times x exponent 1 plus 5 times, now have y, we have y exponent 4 times y exponent 3. So we have y exponent 4 plus 3. So what do we have? So we have 6. 2 times 3, 6 times x exponent 1 plus 5 is 6. Then y exponent 4 plus 3 is 7. So that is that. So you can see that the use of the first law is quite simple. Now we can go further to use the second law. The second law of exponents states that if we have a number a exponent m divided by another number a exponent n. Of course, if we have to show it fully, we have a exponent m divided by a exponent what? N. Remember, a exponent m is a times till m. Okay, so it says that this is equal to a, then the numerator m minus the exponent of the numerator minus the exponent of the denominator. Exponent of the denominator is n. So if we have 3 exponent 5 divided by 3 exponent 2, it means that this is equal to 3 exponent what? 5 minus 2. And this is equal to 3 exponent 3. That is just it. Okay. So we go down to take an example. So in our example, we have simplify each of the following, leaving your answer in exponential form where appropriate. When a, x, and y are rational numbers, but a, x, and y are not equal to 0. So we go for the first one. We have 9 exponent 7 divided by 9 exponent 3. This is equal to 9 into 7 minus 3. This is equal to 9 into 4. 7 minus 3 is 4. Then the second one, minus 4 all exponent 8, then minus 4 divided by minus 4 all exponent 1 is equal to minus 4 bracket 8 minus 1. This is equal to minus 4 bracket 7. Example 3, we have a exponent 10 divided by a exponent 6. This is equal to a exponent 10 minus a minus 6 is equal to a exponent 4. Okay, so the last one, very last one, says 27 x raised to the power 9, y raised to the power 4 divided by 9, x raised to the power 6, y raised to the power 3. So let's write this in fraction of 27 x raised to the power 9, y raised to the power 4 divided by 9 x raised to the power 6, y raised to the power 3. This divide this, it gets it 3. Okay. Now here we have x raised to the power 9, x raised to the power 3. So we have x 9 minus 6. Then we have y 4 minus 3. So this is 3x raised to the power 3, y raised to the power 1, or y. So finally we have 3x raised to the power 3y. So that is how we use the first and second law of exponents. It's very important that you saw how everything is being broken down in this lesson. So if you really enjoyed this lesson, stay tuned for our next video.